All right, we have section 6-7, polygons in the coordinate plane. All right, so we're going to draw a line from each item in column A to a corresponding part in the coordinate plane in column B. All right, so the origin is the intersection of the X and Y axis. Quadrant 1 is right over here. Quadrant 2 is right here. Quadrant 3 is right here. Quadrant 4 is right here. The x-axis is the horizontal line here, and the y-axis is the vertical line here. All right, to classify is to organize by category or type. We classify figures by their properties. So related words are classification or classified. So example, rectangles, squares, and rhombuses are classified as parallelograms. So trapezoids are classified as quadrilaterals. Taxonomy is a system of classification in biology, and schools classify children by age. Okay. So, formulas in the coordinate plane. So these are formulas we're going to be using, and you may have used them before. The distance formula is used to determine sides are congruent or if diagonals are congruent. We're going to use the midpoint to see if coordinates of the midpoint of the side and whether diagonals bisect each other. And we will use the slope formula to determine if opposite sides are parallel, diagonals are perpendicular, and if sides are perpendicular. To decide when to use each formula, we're going to write D for distance, M for midpoint, and S for slope. If you want to know the diagonals bisect each other, I would use the midpoint formula. If I want to know whether or not opposite sides of quadrilateral are parallel, I would use the slope formulas. And if you want to know whether sides of a parallelogram are congruent, I would use the distance formula. All right, so if I know the triangle has vertices at 0, 0, 1, 4, and 5, 2, is it scalene, isosceles, or equilateral? So step 1 is to graph the triangle. So we're going to plot 0, 0, and that's going to be point D, 1, 4, and that's the point E, and then 5, 2, and then that's the point F. Connect the dots. And I can't really tell by looking at it, so what I need to do is check some values. So let's find the distances of all of them. So distance for EF, that's a little big, is, using the distance formula, 5 minus 1 squared plus 2 minus 4 quantity squared. Simplifying, we get 16 plus 4, which equals 20. Let's do DE. So DE would be 1 minus 0 squared plus 4 minus 0 squared, which equals 1 plus 16, which equals square root of 17. And then DF is 5 minus 0 squared plus 2 minus 0 squared, which equals 25, plus 4, which equals 29. So what type of triangle is DEF? Well, since no sides are equal, so triangle DEF is scalene. All right, if I know parallelogram MNPQ has vertices at those points, is it a rectangle? Well, in order to know if it's a rectangle, opposite sides have to be congruent, okay? Or diagonals have to be congruent. So let's find the diagonals. So the distance of MP is 2 minus 0 squared plus 5 minus 1 squared, which equals 4 plus 16, which equals the square root of 20. And let's check NQ. So 3 minus a negative 1 squared plus 2 minus 4 squared equals 16 plus 4, which equals 20. So is it a rectangle? Yes, because the diagonals are congruent. Okay. So we have an isosceles trapezoid at these vertices. What special quadrilateral is formed by connecting the midpoints of those sides? All right, so let's plot the point. We have A, which is a 0, 0. We have 2, 4, which is B. We have 6, 4, which is C. And then we have 8, 0, which is D. So here is the trapezoid that's formed. And now let's connect the midpoints. So here's this midpoint, here's this midpoint, there's this midpoint, and here's this midpoint. So what type of quadrilateral is this? All right, so let's find the coordinates of the midpoint of each side. So we have 0 plus 2 over 2, and then 0 plus 4 over 2 equals 1, 2. For CF, we get 6 plus 8 over 2, comma 4 plus 0 over 2, which gives us 7, 2. For BC, we get 2 plus 6 over 2, 4 plus 4 over 2, which gives us 4, 4. And then for AD, we have 0 plus 8 over 2, comma 0 plus 0 over 2, which gives us 4, comma 0. All right, to the midpoints of the trapezoid, connect them. Judging by the appearance, what does it look to be like? Well, it looks to be like a rhombus. All right, so find the slopes now. So the slopes from A to B to B to C is equal to 2/3, and CD to D is 2/3. This one is negative 2/3, and this one is negative 2/3. Are the slopes opposite segments equal? Yes. Are consecutive segments perpendicular? No. So a special quadrilateral is a rhombus. All right. So a student says a quadrilateral with these vertices is a rhombus because the diagonals are perpendicular. What is the student's error? So let's first draw the quadrilateral here. So we want 1, 2. Here is D. We want 0, 7. Here is E. We want 5, 6. Here is F, and we want 7, 0. Here is G. So underline the correct word. So the diagonals for parallelogram are perpendicular, then the parallelogram is a rhombus. So check whether DEF is a parallelogram. So the slope of DEF is 7 minus 2 over 0 minus 1, which equals negative 5. DG is 0 minus 2 over 7 minus 1, which is negative 1/3. FG is 0 minus 6 over 7 minus 5, which equals negative 3. And EF is 6 minus 7 over 5 minus 0, which is negative 1/5. All right, are both pairs of opposite sides parallel? No. Find the slope of the diagonals now. So slope, remember, is equal to y2 minus y1 over x2 minus x1, which for DF is going to equal 6 minus 2 over 5 minus 1, which equals 4 over 4, which equals 1. All right, EG is going to equal 0 minus 7 over 7 minus 0, which equals negative 7 over 7, which equals negative 1. Are the diagonals perpendicular? Yes. So although the quadrilateral has perpendicular diagonals, it is not a parallelogram, so it cannot be a rhombus. And that's the end of that section.